Okay, today we're going to start Unit 6 and we're going to talk about rational functions. Today we're going to do Lesson 18. I know we skipped Lesson 17. I think the other honors classes did a Lesson 17. I made that one optional for you, and so we skipped it, and we're just going to go to Lesson 18, so we'll be on track with the other classes as well. But this is Lesson 18. Our I can statement or learning objective is I can simplify rational expressions. So we're going to start looking at rational expressions and how we can simplify those, and we're going to look at the domain and how to figure out what the domain is and what the domain can't include. So first we have the definition of a rational expression. It's an expression in the form of P divided by Q, where P and Q are polynomials with Q not equal to 0. And there's a little example. We have a polynomial over a polynomial. Now, if we think about stuff that we already know, something that's rational has to be able to be written as a fraction, so that's why we have the fraction. And an expression does not have an equal sign. We're not solving it, okay? We can simplify an expression, but we cannot solve it. So that's why we're starting with simplifying today. Now, I mentioned when I was going over the objective that we're going to talk about the domain of a rational expression and what can't be included in the domain. So we're going to use that Q cannot be 0. If you have a fraction is always defined unless it has 0 in the denominator. If a 0 is in the denominator, we say the fraction is undefined. And you might remember talking about slope when you had like m equals 5 over 0, that slope was undefined, okay? Because you can't have 0 on the bottom of a fraction. And so that's the same is true here. We can't have 0 on the bottom. So when we look at a rational expression, we have to find what would make the bottom 0, and we have to exclude that, okay? And so that's what we're going to talk about next. So a rational expression is undefined when the denominator equals 0. Okay, and that's what we just said. So to find the values that make the expression undefined, we set the denominator, and we're going to turn the denominator into factors. So we're going to set those equal to 0 and solve, and then we'll get the quantities that make the entire expression undefined. So what you're going to see us do, or see me do, is we're going to take the top polynomial, the bottom polynomial, we're going to break them up into the smallest factors we can, and then we're going to look at those factors in the denominator, set them equal to 0, find those values, and then we're going to simplify the expression the rest of the way and get this simplified rational expression, okay? And so we have to find those values that make the expression undefined, because if you were to graph the original polynomial expression, there would be gaps over those values that make it undefined. And so we have to find those values before we simplify, okay? Because the simplified version, the graph would not match the original graph, okay? So we have to find those zeros first because we're talking about the domain. We're talking about what values work and what values don't. So we're looking at the original expression, okay? So make sure you follow that order with me when you do these problems on your own, because if you don't, you're going to get some wrong answers in Math Excel, and it'll tell you that you're missing some stuff, okay? So like I said, we're going to look at a rational expression. Sorry, I'm tripping over my words this afternoon. We're going to look at a rational expression. We're going to factor the top, factor the bottom, find the values that make it undefined, and then simplify it further. Okay, here's example number 1. We have 3x over 30x squared minus 3x. So first, we're going to factor the top, 3x. There's nothing really I can do with that, so I'm going to leave it. Now the bottom, we have 30x squared minus 3x. I know there's a GCF, so I can pull out 3x, and then in parentheses, I'm going to have 10x minus 1. Okay, now, so I've got it factored, and I need to find the values that are going to make the denominator 0 or make the expression undefined. So I'm going to set each of these factors equal to 0. So 3x equals 0, 10x minus 1. So neither of those can equal 0. Okay, so divide both sides by 3, and I get x cannot equal 0. Over here, I add 1. I have 10x cannot equal 1 divided by 10. And we have x cannot equal 1/10. Okay, so that's going to be part of your answer. X cannot be 0, x cannot be 1/10. And I think in Math Excel, it'll want you to separate them with a comma, and that's okay. You should be used to that by now. Now that we found these, we're going to go back up and simplify. So 3x over 3x will divide out. We put a 1 as a placeholder on top, and on the bottom we have 10x minus 1. And so that's the other part of our answer. Now in Math Excel, I think some of the problems ask you to simplify and then give these values, okay? But what I want you to notice is that you have to do this part on your own before you type it in Math Excel, okay? You need to look at what it is factored, set the bottom factors equal to 0 and solve, and then simplify it after, okay? So Math Excel might be a little misleading there, but make sure you set all of the bottom factors equal to 0. Okay, here's example number 2. We have z squared plus 2z plus 1 over z squared minus 3z minus 4. So I'm going to start by factoring the top and the bottom. So on the top, I can change that to z plus 1 and z plus 1. On the bottom, I can do z minus 4 and z plus 1. Okay, so now before I simplify it the rest of the way, I'm going to set each of these factors equal to 0. So z minus 4 to 0, z plus 1 to 0. All right, add 4. We get z cannot equal 4, and then minus 1. So z cannot equal negative 1. So there are those two parts of the answer. And again, Math Excel will probably, I think it says z cannot equal, and it gives you a blank, and it wants you to put those two numbers in there separated by a comma. Okay, so you would do negative 1 comma 4. So that's what it wants in Math Excel. Okay, now we have to simplify. So z plus 1 over z plus 1, those can divide each other out, and we're left with z plus 1 over z plus 4. So z plus 1 over z plus 4. And that's the other part of your answer. Okay, so just like if we were solving an equation and we had 3 over 3 and we would mark those out, they would divide each other out. That's the same thing we're doing here, just with factors. Anything divided by itself is 1. So that's the property that we're using to get rid of some of these factors and to simplify the expressions. Okay, now we're just going to work out some more examples just so you can see what I'm doing, and you can practice these along with me. I highly recommend that you try a couple before you do them yourself in Math Excel. All right, so we have x squared plus 12x plus 27 over x squared plus 10x plus 21. So I'm going to factor the top and bottom. So the top, I'm going to do x plus 3, x plus 9. And if you don't remember how to factor and you're struggling and you're not following what I'm doing, I'm taking 27 and I'm finding factors of 27, like 1 and 27, 3 and 9, and I'm finding the pair that gives me 12 in the middle. Okay, on the bottom I'm going to do the same thing, so factors of 21 that add to give me 10. It's going to be x plus 7 and x plus 3. All right, so I'm going to take the bottom and find my two values that x cannot equal, and let's see if you noticed a pattern over here. So 3x was just a 0. 10x minus 1, we added 1 divided by 10. Here we had negative 4, and it couldn't be 4. We had positive 1, and it couldn't be negative 1. That's very similar to when we were finding the solutions of our polynomials or finding the solutions of quadratics. It's the opposite, okay? So you can skip this middle step of working out those little equations if you can do them in your head. So for this one, I'm going to just do it in my head. I know that x cannot equal negative 7 or negative 3. Okay, now I have x over 3 over x or x plus 3 over x plus 3. So I'm left with x plus 9 over x plus 7. Okay, example number 4. 2, there's nothing really we can do with it. X plus 6, there's nothing really we can do with that either. So that's just your simplified expression. But we need to know what x cannot be. So it cannot be the opposite of 6. So x cannot equal negative 6. Okay, so sometimes your expression will already be simplified and you just have to figure out what the x cannot equal, or what the variable can't equal, or what will make the expression undefined. All right, number 5, we have x plus 1 over x squared minus 1. So the top, there's nothing we can do. Now the bottom is the difference of two squares, so that's going to be x minus 1 and x plus 1. Okay, so before I simplify, I need to know what makes the expression undefined. So x cannot equal 1 or negative 1. Okay, it's the opposite of those. Now I can simplify. The x plus 1's divide out. I have 1 as a placeholder and x minus 1 on the bottom. Okay. Number 6, we have x squared minus 12x plus 36 over 4x minus 24. All right, so let's factor the top. Let's see. Multiplies to give me 36 and give me negative 12, so that's going to be x minus 6 and x minus 6. On the bottom, my GCF is 4, and that leaves me with x minus 6. Okay, so on the bottom, so we don't do anything with the 4 because there's not a variable there, so we just don't worry about that for now. So we just do x minus 6 equals 0. Okay, so x cannot equal 6. All right, now we can simplify. X minus 6 over x minus 6 divide out, and we're left with x minus 6 over 4. All right, number 7, 2x minus 6 over x squared minus 6x plus 9. All right, so let's look at this one. On the top, we can pull out a 2. So that leaves me x minus 3 on the bottom. Let's see, x and x. Let's see, negative 3 and negative 3. All right, so on the bottom, so that ends up being the same thing. We have x minus 3 equals 0 and x minus 3 equals 0. Those are going to solve the same. And so we have x cannot be 3. And then if you simplify, we're left with just 2 over x minus 3. Okay? And then one more, very last problem. We have x minus 2 over x squared plus 10x plus 9. So the top, there's nothing we can do. On the bottom, this can be x plus 1 and x plus 9. Okay? And then, yeah, that's right. So what can x not equal? X cannot equal negative 1 or negative 9. And nothing here simplifies, so that's just as simple as it will go. So on Math Excel, I can't remember if it wants you to type it in this way, or it might not even ask you. On this one, it might just want to know what makes the expression undefined. Let me double check that real quick before I let you go. Oh yeah, so the one that looks like this that won't simplify in Math Excel, it just wants to know the numbers that make the expression undefined. So you should only have to find that, okay? But just know this is as simple as it's going to be, or you could break it up into factors. Okay, so hopefully this assignment isn't too much. I'm hoping that it's kind of easy for you, and once you get the hang of it, you're just doing the same thing over and over. You really need to be up to par on your factoring. If you need help with factoring, let me know. I'd be happy to assist you. But if you can factor, this shouldn't be a problem for you. All right, so use these examples to do your work in Math Excel. If you have any questions or need help, please let me know. I would be so happy to help you with anything you need. Okay, you just have to let me know. Have a great rest of your day.